Show you some really cool science experiments with a soda can. We're going to start with this easy experiment which you can try at home, balancing a Coke can at an angle like this. Then later I'll show you how you can do it on the edge of your glass too. It looks crazy, like it should just fall over. But balancing it on a table is actually pretty easy. Pour out about 3/4 of your drink, then with a steady hand give it a go. It might take you a little trial and error to set the balancing point with the right amount of liquid in the can, but once you've got it, it should stand perfectly on the lip. And what's really cool is you can even give it a gentle push and roll it around on its rim. And if you stay around until the end of the video, I'll show you a little trick for balancing it on the rim of your glass too. But first I'm gonna dissolve this can to reveal something really cool inside. I'm starting with a full can of Coke which I'm leaving unopened. Then I'm taking a strip of sandpaper and I'm using it to remove all the paint off the can. And after I've cleaned it up, it looks like this. We've exposed the aluminium under the paint and we can now open up the can. For the experiment, I'm going to be using this drain unblocker. It's pretty nasty stuff, so I'm wearing rubber gloves. I poured some into this glass beaker, and I'm putting it on this plastic tray. Next I threaded a skewer through the ring pull of the can, and I'm lowering it down into the drain cleaner. You can see straight away bubbles started forming around the can, and I topped it up a little to try and cover some more of the exposed aluminium. The idea is the drain unblocker should eat away at all the aluminium and dissolve it. Let's see what happens. It produces a lot of bubbles, and these are actually hydrogen gas bubbles, so I'm doing this somewhere safe outside with lots of ventilation. After about an hour, you can see the liquid has started turning dark brown. You might think that the Coke can has dissolved, leaving the Coke to pour into the drain cleaner. But let's take a look. As we lift it out, you can see the can has completely disappeared, but the drink is still inside and holding shape. There's actually a plastic coating inside of the soda can, which keeps the drink fresh and stops it tasting metallic. So we've completely dissolved the can and kept the plastic coating. Pretty cool, huh? If I tip the drink into a glass, you can see it a little better. It's really crazy. And it still keeps the shape of the can. I washed it off, and you can even refill it with water. The plastic feels very thin, but it's actually tough enough for me to play around with a little. Oh, and there we go. It's finally ripped. If we take a closer look, you can see how thin it is. It's almost like cling film. I decided to do the experiment again, but this time I only sanded down parts of the can. I wanted to see if the painted layer actually stops the can from dissolving. And this is what we got. You can see the paint did a great job. The bare aluminium dissolved, and the rest is still intact. A couple of years ago I made a video where I abraded the surface of a can and added a small amount of gallium metal. After a couple of hours, the aluminium sort of absorbed the gallium and it became soft and almost stretchy. I could just tear it apart. Today I'm repeating the experiment, but this time I'm using a full can to see what happens. So I abraded the surface, then took some gallium, which is non-toxic and solid at room temperature, and I heated it up in some warm water. I gave the can a good shake to try and encourage something spectacular to happen. Once the gallium had warmed up to the point where it's liquid, I put some in a syringe, and I added it to the can. After about half a minute, the gallium burst the can and released the pressure, blowing a blob of gallium clean off the surface. Next I took another can, and I sanded off a bit of paint from the sidewall here, and the top too, to try another one. I added some gallium to the top, and again, it burst straight away. Then I also added some to the side of the can, which was a bit tricky. And look what happens now if I add some more gallium to the first can. It just disappears through the surface. Crazy, huh? I left both cans to stand for an hour, then I took a look. When I tried to open the first one, the ring pull just came off in my hands. And the top of the can has just melted. I can sort of peel it back. And you can see this time the Coke is still inside. I'm using a skewer to have a little poke around and peel it back. Oops, I think a piece fell down inside. You can see the sidewalls of the can haven't been affected. Only the top, which is why on the second can I also put some gallium on the side. Let's have a look at it. Well, despite the gallium having punctured this can immediately, the top is still solid. And so is the side. So I decided to sand off some more of the paint and try again. This time, after I left it, the side had become weak in this area on the back, and also this little patch on the front. But it didn't really spread more than that. It does look amazing though. And the top of the can still seems pretty unaffected. So I removed this piece of gallium and scratched away a little. You can see a little hole where it compromised the can at the beginning, but for some reason it didn't affect the whole top section this time. If you want to see more fun gallium videos, you can take a look at my YouTube channel. There's links in the description. This next experiment is pretty cool and it's one you can easily try at home. Pour a little water into an empty can, then gently heat it up on the stove. Next, take a bowl of cold water, then when you see steam coming out of the can, use some tongs to pick it up near to the base. Then quickly turn it upside down and dip it into the water. It instantly implodes and crushes itself. So what's happening here? As we heat up the water in the can, it creates a water vapour, which increases the pressure inside of the can. When we dip it into the water, this vapour condenses and now reduces the pressure inside of the can. And because the opening is sealed by the water, the reduction in pressure causes the can to be crushed. It's a fun little experiment. So finally, I'm going to show you how I balanced this can on the rim of a drinking glass. If you're enjoying this video and you're new here, you can make sure you don't miss any of my future content by subscribing and ringing the bell. So I tried this trick over and over, with different levels of liquid in the can and different drinking glasses. But I just could not get it to balance, however I tried. So I decided to replace the Coke with something uncarbonated and something that doesn't slosh about in the can so much. So I put in a few spoonfuls of rice. This should act as a damper. Then I added a splash of water. Again I tried and tried, but could just not get it to balance on the rim. So, as a final solution, I used the handle of a spoon to make a little dent or impression in the can here. It's almost unnoticeable, but just that tiny little dent was enough to allow me to get the can to balance. You can see there's no wires or strings, and the can sits there by itself.